Hello students, we'll be continuing our discussion. We were discussing J Advanced 2023 questions. So we are continuing it. Let us go to this question. See, f from 0, 1 operand 0, 1 to r be the function defined as f of x is equal to root of n. F of x is equal to root of n. And if x, where x belongs to 1 by n plus 1, 1 by n, x belongs to 1 by n plus 1, 1 by n, closed interval 1 by n plus 1, open interval 1 by n. And where n belongs to capital N is a natural number, okay. And let G is another function whose domain is open interval 0, 1. G is defined from open interval 0, 1 to R, set of real numbers, be a function such that integral from x square to x, root of 1 minus t by t dt less than g of x less than 2 root x. So an inequality, a function whose lower and upper bounds are given. So integral from x square to x, let us write it over here, integral from x square to x, okay, root of 1 minus t by t dx dt less than g of x less than 2 root x, So over here, see, x belongs to 1 by n plus 1, x belongs to, say, open closed interval 1 by n plus 1, comma 1 by n, okay. For example, x belongs to, where n is a natural number, n can be any natural number. For example, 1 by 290, let it be 1 by 300 to 1 by 299, etc. like that, okay. Or it can be in between. So this is a number between 0 and 1, okay. So open interval 0, 1. So it can be anywhere over here, anywhere from between 0 and 1. So, and for all x belongs to 0, 1. So x belongs to 0, 1 means x is of the form what? X is of the form 1 by n. X is of the form 1 by n. F of x is equal to what? Root of n, where n can be written as 1 by x, because x is equal to 1 by n. This is the form of 1 by n, therefore n can be written as 1 by x, okay, 1 by x. So, and then limit extends to 0, fx into gx we have to find out. We have to find out limit extends to 0, f of x into g of x. So this is the inequality given, okay. So, you know, fx from 0, 1 to r, and f of x is equal to 1 by root of, f of x is equal to root of n. So where n is a natural number, so n is obviously, n is greater than 0. So we can assume that we can very well, without loss of generality, we can say that fx is a positive quantity. So what I am going to do is, I multiply the entire thing with the f of x. That is what we have to find out, okay. And we take limit extends to 0. Okay. So that is what we have to find out. Limit extends to 0, f of x into g of x. So I multiply by f of x, limit extends to 0, f of x is into integral from x square to x, root of 1 minus t by t, okay, into dt less than limit extends to 0, f of x into g of x, which is again less than limit extends to 0, f of x into 2 root x, and we know that fx is of the form 1 by root x, which is definitely a positive quantity. So I replace it with 1 by root x. So limit extends to 0, integral over x square to x, root of 1 minus t by t dt into 1 by root x. Okay, fx is 1 by root x, into dt less than limit extends to 0, f of x into g of x, less than limit extends to 0, 1 by root x into 2 root x. 1 by root of x into 2 root of x. Now over here what we can do is that root x we can cancel. root x we can cancel. You will be getting the right boundary as limit extends to 0 2, therefore that is 2 only. Okay, it is less than 2. Now let us take this limit, let us denote it by L. Let L be the limit. So that is less than this, this we have to find out. This quantity we have to find out. Now this is of the form 0 by 0, because when x tends to 0 means integral from 0 to 0. Integral from 0 to 0 is 0 only. 0 by, again, denominator is also 0. So it is of the form 0 to 0. So here what we can do, we can apply Leibniz rule of differentiation under integral sign. According to Leibniz rule, or we are applying Leibniz rule. Okay, so when you differentiate both numerator and denominator, and what is Leibniz rule? That is, we have to apply, we have to differentiate it. See, the limit of, the derivative of x square, derivative of x is 1, okay, into root of 1 minus x by x, because we differentiate this x and put x into the bracket, okay, put x into the function, minus 2x into root of 1 minus x square by x square, okay, root of 1 minus derivative of x square. Derivative of x square is what? 2x into root of 1 minus x square by x square divided by derivative of root x is 1 by 2 root x. 1 by 2 root x. Okay. So that less than the limit L less than 2. Okay. Now see over here, this x square root is what? X square root is x only. So we can do one thing. We can cancel this x square. Square is root x. So this root x and this root x cancels. Okay. Because this will become what? X and so this is x and x cancels. So it comes outside. Okay. X and x cancels. Okay, I will do like this. Better we do like this. Let us take it as root of 1 minus x by x. Root of 1 minus x by x. Root of 1 minus x by x. Minus 2x, and this is x square and x cancels, because this is x, root of x square is x, it cancels. So minus 2 in root of 1 minus x square, divided by 2 root x, this will go to the numerator, okay, into 2 root x, less than L less than 2, okay. Now over here we apply the limit x tends to 0. Again, when you apply this 2 root x into the bracket, you will get root of 1 minus x, because root x and root x cancels. So 2 in root of 1 minus x minus, or here it is minus 4 into root x into root of 1 minus x square. Okay, less than the limit L less than 2. Okay. Now again, when you apply the limit x tends to 0, what is the limit of this? This is 2 in root of 1 minus 0, this is 2. Minus this will become 0, 2 minus 0 less than L less than 2, okay, less than L less than 2. So that means the limit is lying between 2 and 2. That means what? According to the Sandwich theorem, okay, according to the Sandwich theorem. What is Sandwich theorem? If the limit is lying between two finite numbers, if the limit of a function is lying between two finite numbers which are same, okay, then the limit is equal to what? 2. The limit of the given function is equal to 2. So that is what. So here the limit of this function, limit of fx gx, which lies between 2 and 2. That means when x tends to 0, this limit coincides with the 2. So that is limit L is equal to what? 2. Okay. So that is a very simple question actually.